Hey guys, welcome back. So right now we're talking about the ammonium ion, the hydroxide ion, the nitrate ion, sulfate ion, carbonate ion, and the hydrogen carbonate ion. Now out of these six, the hydrogen carbonate ion is probably the least important, but these other five ions show up a lot, so we're introducing them early in the course, right? Now, what exactly do you need to know about these compound ions? And they're called, for one thing, compound ions because they're different atoms joined together and the whole thing is acting as one ion. Same for hydroxide, same for nitrate, same for sulfate, carbonate. What you need to know right now over here is that their name, their chemical formula, and the charge on them, right? What do I mean by that? Let's look at an example. Let's say in a question it says calcium carbonate and you want to know the chemical formula for calcium carbonate. Now over here you need to know exactly how the carbonate ion, what it looks like and what charge is on it. By what it looks like, I mean its chemical formula, not its shape, how we saw in the last slide. So calcium we know is just calcium with 2 plus and a carbonate ion is CO3 with a 2 minus charge. At this point you can figure out that calcium carbonate has to be calcium CaCO3, right? Why is because the total charge on the carbonate ion is 2 minus, whereas the charge on calcium is 2 plus. So they balance each other out if they're 1 to 1. So it's just calcium carbonate. A little different example when you have sodium sulfate. You have sodium with a positive charge and sulfate with a 2 minus charge. Sulfate ion is SO4 2 minus. So don't you need twice as many sodiums to balance this charge out? Yes, you do. And that's exactly how it ends up bonding. It becomes Na2 SO4. So compound ions, they end up looking scary and very alien-like, but the result is very simple. You just react them how you react. You just try to figure out what the compound is by similarly how you figure out any other ionic compound, like calcium chloride. Calcium carbonate will be CaCO3 because the charges are balanced out. Again, you need to know the charges and the name and the formula of these compounds. So these five, try to absorb them as much as you can, like know their chemical formula and their charge on them. Here's an example of sodium carbonate, very similar to sodium sulfate, which we did, because sulfate has the same charge as the carbonate ion. So the example explains that for sodium carbonate, the ions are sodium and the carbonate ion. These two you already know. This you can look at the periodic table. This you kind of need to know. 2 sodiums are needed to balance out the charge for the carbonate ion. So the resulting product has to be Na2CO3. In the case for calcium nitrate, you need a calcium and a nitrate ion. Now, what's unique about the nitrate ion, it has a negative charge, just -1. So you need more of the negative ion this time, but you don't just write CaNO3 times 2, or like how would you highlight that it's this ion you want 2 of? You cannot write CaN2O6 or anything like that. That would be wrong. So what you end up doing is how it's shown over here. You just say Ca and 2 nitrate ions, so you put it in a bracket and you go twice. Here's an exercise we can do. We can try to figure out these 9 compounds. So sodium reacting with chlorine, sulfate ion, hydroxide ion, calcium reacting with these 3, and aluminum, the product of these 3. Okay. So let me just make my life easier and put the charge on top of them. Sodium is plus, calcium is 2 plus, aluminum is 3 plus. Whereas I have chlorine over here, 2 minus, and minus again. So this looks much easier all of a sudden. This has to be NaCl because 1:1. We've seen this before. It's Na2SO4. This is just NaOH. Okay. Over here it's going to be CaCl2. This This is going to be CaSO4. We've seen this before. And this is going to be Ca. Now remember how I put the bracket last time, right? Twice. This is AlCl3. This is Al2SO4, but thrice. And the last one is AlOH thrice. Okay. All right, write down the symbols for each of these ions and then work out the formula for each compound. Let's try doing that. Let's make a neat line over here like this. Potassium chloride would be Ka plus and Cl minus. Calcium is 2 plus, SO4 2 minus. Lithium would be just plus, right? It's in group 1. Yeah. And oxygen would be 2 minus. Magnesium would be Mg 2 plus with fluorine with a minus charge. All right, how would they bond? Well, that's easy now, right? It's just going to be KCl, CaSO4. We've seen this quite a few times now. This is going to be Li2O and MgF2. Okay. All right, work out the formula for each of the compounds. Now, when you have a transition element, right? When you have a transition element, the charge on that element, that metal, is variable. It could be anything, right? Depending on the type of metal you have. So how do you know what charge to use? So, for instance, copper generally exists as in its ionic form either as copper plus or it could be copper 2 plus. So what they do is they highlight the charge on the copper, on the metal, on the transition metal in Roman numerals right next to it. So this is called copper 2 chloride, copper 2 chloride. So that implies it's just a copper ion with a 2 plus charge, this one, right? So if you have that, copper 2 plus with a chloride ion, which is still Cl minus, group 7, group 17 element would have the same charge, doesn't matter. How would this bond? It's going to be CuCl2. How about iron 3 oxide, the second one? What's the charge on the iron? 3, right? Because the Roman numerals are telling you what the charge is. So it's iron 3 plus with oxygen, which is obviously going to be 2 minus. I do the swappity swap, and it's Fe2O3.